All right, so which geographic regions are going to be at risk when we talk about tropical and extratropical cyclones? So different areas in North America overall are going to be affected by these type of cyclones, obviously. So on tropical cyclones, the areas that are going to be mostly affected are going to be areas in the Gulf of Mexico and the Gulf Stream. Areas that, excuse me, areas that are also going to be on the east coast are going to be greatly affected by tropical cyclones. So also areas in Puerto Rico, which is a U.S. territory, also the Virgin Islands are going to be also affected. In some other U.S. territories and the Pacific Ocean may see an effect from these tropical cyclones. Less effect is going to, or less threat is exposed to Hawaii, for example, and also to Canada, but it is still a possibility that they will see hurricanes. One of you, if I'm not wrong, is doing their class project on a hurricane that hit Hawaii. So there you go. So it still happens, and it's a pretty big deal when it does. Also, in the Pacific coast, areas such as Baja California in Mexico and the western coast of the Mexican mainland, such as the area in Jalisco and Nayarit, are very greatly affected by hurricanes. Not nearly as much as, the Gulf Coast or the eastern part of the U.S., but still very much so. So, in average, the U.S. sees 5 major hurricanes, and the East Coast and the Gulf Coast every year hit the mainland itself. Most of the threatened hurricanes were ones that formed in Africa, not ones that started forming in the Caribbean or even in the Gulf. Those tend to be minor tropical storms. So the most threatening ones are ones that have been forming for a long time, since in the Western Africa region. So usually, or officially I should say, the hurricane season in North America goes from June 1st till November the 30th, but it varies. Having most of the hurricanes occur between August and October. September usually being the month where the most damaging ones occur. Okay. The regions that are at risk for extratropical cyclones is much greater. This includes the Greater Plains, the Pacific Coast, east of the Rockies, and also near the Sierra Nevada. So all those areas, which overall is a little bit larger areas, tend to be at risk for extratropical cyclones. This little image over here shows you areas that are at risk for tropical cyclones, and it shows you to which risk they are at. That sounds funny, but you see here that the areas that are most at risk or have the highest risk are going to be areas in the Georgia, South Carolina, North Carolina, and Florida area. Then pretty high is going to be pretty much all of Florida, a little bit of Georgia, the Carolinas, Louisiana, Alabama, Mississippi areas, a little bit of Texas. And then moderate risk is going to be pretty much anything that is in contact with the ocean, up to maybe 200 miles inland, that is in the Gulf Coast or in the East Coast of the U.S. So a lot of areas. In particular, I want to point out, for example, Florence, which hit the Carolinas earlier this year. I think it was early September now. It's been a while since, or mid-September. Happened actually right here, right where the highest risk is at hand. And then Michael, which hit pretty much this area of Florida, and it tracked up northwards, hit the area that is blue or darker blue, the high area of risk this year as well. So although I have focused my talk today on North America, that is because that's where we live, and that is because that's where most of the people that we relate with are as well. Many of the regions worldwide are also exposed to these tropical storms and extratropical cyclones as well, right? So actually, the Northwest Pacific generally has 3 times the number of hurricanes as the northern Atlantic Ocean. So as you're seeing here, Asia is hit by hurricanes way more than we are. In fact, the Pacific and Indian Oceans overall have more hurricanes as well. So again, all of this area, as you're seeing in the image, has more activity going on than the area of the northern Atlantic, which is what we see for the most part in North America. There is one area or one major sort of tropical area in the world that does not see tropical storms and hurricanes going on, which is pretty much the area of South America. You don't have anything in the South Atlantic, or you don't have anything in the southeastern Pacific either, or in the South Atlantic towards the east either. So towards Africa, you don't have anything, and that is because of their cold surface waters. So because you have cold surface waters, you basically have no moist air, no moist waters and warm to be able to even start the tropical disturbances. So that is why we don't have anything going on in that southern part of the world. However, as you're seeing here near Australia and near Madagascar and whatnot, you do have a fair amount of cyclones. Okay, so, and as you know, these tropical cyclones, can't form near the equator because of the absence of the Coriolis force. So that is why you have this band of nothing really going on pretty much at the equator, right? And also, once they form either north or south of the equator, they cannot cross past the equator because of Coriolis force. So it would just pretty much completely diminish and stop the rotation within the center there. All right, so both types of cyclones, either tropical or extratropical cyclones, are going to cause pretty major flooding, thunderstorms, and tornadoes, as you might know. However, extratropical cyclones can cause snowstorms and blizzards as well, given where they occur. There's three major events that I want to touch base on, and those are going to be storm surges, high winds, and heavy rains. And those are going to be mostly concentrated for tropical cyclones, but they also occur for extratropical cyclones. So some of it is going to be relevant for them as well. So stay tuned. So that first effect is, again, storm surge. So storm surge is officially the local rise of sea level that results primarily from water that is pushed towards the shore by the winds that swirled around the storm. So you might have seen some images of movies and whatnot of the storm surge being shown kind of like this massive waves, kind of like tsunami wave style. Usually storm surge does not happen that way. It's more like a fairly rapid but still gradual rise of the sea level. So it's not going to happen in this major waves coming over and overtaking the city like a tsunami, but rather it's going to happen fairly fast, but still just like if you were filling up a bowl with water. That's how the whole storm surge is going to look like. So typically it's going to be 3 meters storm surge for hurricanes and intense extratropical cyclones. So that's a whole lot of water. That's 9 to 10 feet of additional water that the sea level is going to see. Actually, in Bangladesh and Australia, storm surges have been recorded of 12 meters high. 12 meters, guys. What is that? It's almost 40 feet high. That's insane. But anyways, so one thing to have in mind is that the larger the cyclone, the more capacity to create a greater storm surge. Okay, so that's just pretty intuitive, but again, the larger the cyclone, the more capacity to create a greater storm surge. So for most hurricanes in the northern hemisphere, the storm surge is greatest in the right forward quadrant of the storm as it makes landfall, and that's given the rotation that it takes, based on the Coriolis effect, because they're deflected towards the right. If it was in the southern hemisphere, it would be in the left in the left forward quadrant of the storm. Okay? All right. So the height of the surge is usually greatest near the time of the maximum wind speed, which is also intuitive. And it's also greater if like the landfall of the hurricane occurs during high tide, which also makes sense, right? So during high tide, you tend to have also higher sea level. So if it happens during high tide, then you're gonna get even more water than you would see during, for example, low tide times in a specific location. So storm surge itself is the effect that causes 90% of hurricane damage overall. So 90% of the damage, lives taken, money that is being spent to repair things happens because of this one effect, which is storm surge. So, and that makes sense, right? Flooding can be such a painful thing to deal with. And this is basically just gigantic amounts of flooding in very fast periods of time. Okay, so there are two mechanisms that cause storm surges in the cyclones. The first one being a lot more important, if you would, or a lot more likely to cause a storm surge or a greater storm surge than the second one. So the first one is going to be stress that is exerted by wind on the water surface. So as the winds grow stronger, the water level rises quickly, with the height of the water being proportional to the square of the wind speed. So here's a little scenario. So if my wind speeds were of a category 1 hurricanes, call it 120 kilometers per hour within it, right? If for whatever reason my inner wind speeds got greater to, let's say, 124 kilometers per hour, that's pretty much a 3% increase in wind speeds. So because I increased it 3%, and the storm surge, like the height of the water from the storm surge is proportional to the wind speed in a square matter, then that means that my storm surge is going to be 9% more likely or greater amount of water than it was in my 120 kilometers per hour scenario. Does that make sense? Because 9 is the square of 3. So if I increase 3% my wind speed, then I'm going to increase my storm surge 9%. Or if I increase it 2%, the wind speed, then my storm surge is going to increase 4%. So hopefully that makes sense. All right, and then another mechanism is going to be the low atmospheric pressure in the storm that pulls up the sea surface. So again, this one is considerably less important than the first one. But basically how it goes is that for every millibar that atmospheric pressure drops, the sea rises about 1 centimeter. Okay? So that means that, for example, in the most intense types of hurricanes where the atmospheric pressure drops about 100 millibars, then you would see 100 centimeter rise in the sea level, which is a meter or 3.3 feet. So that is how much it could possibly rise with this storm surges based on the atmospheric pressure change. Whether with the wind speed, it could rise easily 10 meters depending on overall the wind speed changes. But it is a lot greater effect. So it's also affected by the shape of the coastline itself. So it's going to be greater. So the storm surge is going to be greater when you have narrow bays, lagoons, or even lakes. So think of the Great Lakes in this example. And that is because the waves that are built up as the slush goes back and forth in that coast, right? So if you think of just a narrow bay, there's going to be waves that are going back and forth within the two different coasts. And that's going to create this resonance, which is going to make the water basically build up a little bit more so. So overall, the storm surge is, again, a slow rise of water, not an advancing wall. So that's very important to keep in mind. That the damage overall comes from the superimposing storm waves, which usually cause erosion of beaches, islands, and roads. So the eroded material that is carried inland is called the overwash. Okay? And then much overwash. that's much overwash material that is deposited at the end of the channels is going to be called the washover channels. So I'll pick up here in the next video.